In this video, we'll be hosting a .NET 8 Web API to an AWS EC2 instance using Docker. We will be building a .NET CRUD API that's integrated to a PostgreSQL database instance to perform basic CRUD operations. We will also provision and configure a free EC2 Linux instance, SSH into the instance from our development machine, and pull the .NET source code from GitHub. We'll also have to install the required tools and SDKs like .NET, Git, Docker Compose, and Docker. This ensures that the entire setup works. So once these are installed, we'll build a Docker image from our .NET API and use Docker Compose to spin up two containers for the .NET API and the PostgreSQL instance. We will then expose the 8080 port to ensure that our API is publicly accessible. So that's a lot to learn from this video. I'm pretty sure that by the end of the video, you would have gained enough knowledge to deploy your own .NET apps into EC2 instance the right way. Hi everyone, this is Mukesh from codewithmukesh.com. If you're new here, do subscribe to my channel. I post content around .NET, AWS and related stack that might help you in your development career. Thanks to AWS for sponsoring this video, which is part of my ongoing .NET on AWS series, for which I have already posted a couple of videos and articles both on my YouTube channel as well as on my blog. I will leave the links below in the description in case you want to follow along with the series. Let's get started. As usual, here are the prerequisites you are expected to have to follow along with this video. An AWS account, authenticated development machine, .NET 8 SDK installed, some terminal experience with Linux commands, Visual Studio IDE, and Docker Desktop. Let's talk about one of the core building blocks of AWS Compute Service, which is EC2. Now, if you're looking for a highly customizable, low-level service that gives you full control over your servers, EC2 is probably what you're looking for. But like most of the things, that kind of flexibility comes with its own pros and cons. First, the good news. EC2 lets you configure and control your virtual servers just about any way you want. You get to pick the instance types, optimize performance, and manage things right down to the hardware level. This makes it a great option if you need total control over the infrastructure you're running, like if your organization has some specific compliance needs or specialized workloads. But here's the flip side. Because you have so much to control, you also have to take on the responsibility of setting everything up and maintaining it. There's definitely some operational overhead involved. You will need to configure networking, security, storage, and everything else. So while EC2 offers maximum flexibility, it also requires a bit more hands-on management. Now, one of the biggest advantages of EC2 is the variety of instance types you can choose from, which means that you can optimize costs based on your needs. Whether you're running compute-heavy applications or something more memory-intensive, you can select just the right instance for the job. This makes EC2 not only powerful, but also a pretty cost-efficient option, especially when you start leveraging AWS various pricing models. It's a super reliable service with the ability to fine-tune things as your workload evolves. So, if you need complete control over your server infrastructure and don't mind the setup work, EC2 can be a great option to consider. It's flexible, powerful, and when configured right, it can be pretty cost-efficient too. Next, let's talk about the pricing for EC2 because this is where things get pretty interesting. AWS offers several pricing models that can help you optimize costs depending on your specific use cases. First, we have the on-demand instances. This is the most flexible and the popular option. You are essentially renting compute power by the hour or second, no strings attached. This is perfect for short-term, unpredictable workloads. But keep in mind, this flexibility comes at a higher cost compared to other pricing models. Next, we have the reserved instances, which are great if you know you will be running workloads over a long period of time, like maybe 1 year or 2. In exchange for committing to 1 to 3 years usage terms, you can get up to 70% off from the on-demand rates. So if you're planning for steady workloads, this can be really something that you must check on. Then we have spot instances. Think of this as buying up AWS's leftover capacity at a huge discount, sometimes maybe even up to 90%. So what's the catch? Your instances can be terminated with little to less notice. But for the tasks that can handle interruptions like batch processing or big data crunching, spot instances are a fantastic way to save. Another option you have is savings plan. This offers flexibility similar to the on-demand instances, but with discounts for committing to consistent usage over 1 to 3 years. It's less rigid than reserved instances because you're committing to a dollar amount per hour rather than specific instance types. Finally, if you need your own physical server for compliance reasons or software licensing, AWS offers dedicated hosts. So these are more expensive, but gives you complete control over the hardware your instance runs on. So depending on your use case and workload, you can choose the pricing model that fits best and really optimize the costs. In previous videos, I have already covered other AWS compute options like ECS Fargate, Lambda, Elastic Beanstalk, and App Runner. If you haven't checked them out, be sure to take a look. And let me know in the comment section what you think might be the best hosting solution for your .NET application. I'm thinking about putting together an article comparing all these compute services side by side to help you make more informed decisions. So if that's something you would like to see, drop a comment down below. Here is what we are going to build in this YouTube video. An ASP.NET Core 8 Web API which performs CRUD operations against a PostgreSQL database. This Web API will have built-in Docker support, which I'll be showing further in this video. We'll also be writing a Docker Compose file with instructions to deploy both the application and database to the Docker container. The source code will be hosted on GitHub. We'll configure and launch an EC2 instance and pull in the source code from GitHub. So this is like the main part of this entire video. All the required runtimes and SDK will be installed onto this instance. We will then SSH into this instance using Windows Terminal and the PEM keys generated from AWS. The .NET Applications Docker image will be built on the Linux instance itself and launched via Docker Compose. So both the application and database will be deployed to the container in this instance. Finally, the port 8080 on which the Web API will be running will be exposed to the public so that we can publicly access it and test it. Next, let's explore the .NET source code that I have built for this demonstration. This entire source code will be available on my GitHub, for which I will be providing a link in the description of this video. First up, we have included the built-in Docker support, which can help you build Docker images even without writing any Docker files. So if you want to learn more about this, I have an entire article around this on my blog. Also, as mentioned, I have included the EF core and the Postgres NuGet packages for this. Now coming to the domain folder, we have the book entity, which is like the main entity and rather a very simple one. So we are going to perform CRUD operations against this particular entity on the database. I have wired this up with a DB context file, as you can see here, and also I have generated the migrations. And coming to the program.cs, you wouldn't have to add or apply any migrations as such, as I have already added them in the code to fetch the pending migrations and migrate it automatically for you. You will just need to ensure that you have specified the correct connection string in the appsettings.development.json, as you can see here. Also, ensure that in the appsettings.docker.json, you have the default connection string to point to the Postgres container that will be running in your Docker container. Let me close this up. And as you can see, I have all the minimal endpoints set up, that is getting all the books, getting a single book and posting a new book or creating a new book. Also, here is a book service interface that we are going to perform CRUD operations with. As mentioned earlier, we have provisions to get all the books, get a single book by the ID and create a new book. Finally, let me open up the Docker Compose file that you can see here. So this is going to spin up both the .NET application container as well as the database instance. As you can see, we have two services, that is the API and Postgres. The API points to the .NET image that we are going to build attached to the latest stack. It also sets the exposed port to 8080 and also notice that the API service depends on the health status of the database, meaning that the API service would be up and running only after the database container is considered healthy. Next, we have the database service which points to the latest Alpine version of PostgreSQL and sets some default credentials, volumes, ports and health checks. That's all for the code. Let's now jump into AWS and learn how to set up EC2 instance. Let me switch back to the browser and open up AWS Management Console. So if you don't already have an account on AWS, please create a new one using the free tier, which is more than enough for you to test out services. You can find some free AWS credits in the video description too, so do not miss that out. Let's switch back to AWS console and search for EC2. And let me open up in a new tab. So this is what you're going to see when you first launch EC2. Let's hit on launch instance. I will name my instance as demo. And here you can see that the free tier would give you up to 750 hours of T2.micro and other benefits for the first year, which is more than enough for building and testing out applications. Now let me go to the application on OS images and select Amazon Linux. I prefer this OS since it's well integrated with other Amazon services. Ubuntu also can be a good and cheap option to host .NET applications. For now, we'll proceed with Amazon Linux. I will keep the Amazon machine image as the default, which is the latest Amazon Linux 2023. And also, make sure that you have selected the architecture as 64-bit. Now under the instance type, we'll get to choose the hardware configuration of your server. You can choose anything from 1V CPU, 1GB memory, up to 64V CPU and 1024 gigs of RAM. This is all based on your workloads. For our application, T2.micro will do the job and also it is included in the free tier. So let me select that. Now to SSH into the instance, we'll need a security key pair. Let me click on create new pair. I'll name it something like demo and keep everything as the default. Note that if you're going to use Windows terminal to SSH into the instance, always select the .pm extension. If you wish to use PuTTY, we'll go with ppk. For now, I'll select pm and click on create a new pair. I'll have to download this file and keep it safe. At a later point, we'll have to modify the file's permission so that we'll be able to SSH into the instance using this PEM file. Now let me scroll to the network settings and leave everything as the default. Note that this will create a new security group and allow traffic from everywhere. Also, at a later point of time, we'll have to come back to the security group to expose the port 8080 to the public. For the storage, I'll select it as 24 gigs. Keep everything as default. There is also one more thing I wanted to highlight here. Let me click on Advanced tab and scroll to the end of it. Under user data, you can add scripts to run soon after your instance is created. This can be helpful when you want to create multiple instances and don't want to waste time in SSHing into each of these instances and installing all the required packages and SDK. For example, I have already included the scripts in this GitHub repository that are needed to install all the required packages and SDKs for this demonstration. So feel free to use them. For now, we'll not be using them. Rather, we'll directly SSH into this instance and install one by one so that you get a better understanding of the whole process. So let me go back. Also to review the configurations before you proceed. So once that is done, click on Launch Instance. Give it a couple of moments and your instance should be ready anytime. Now once the instance is ready, click on the instance ID to open it up. So let me open it up in a new tab. So here you get the entire summary of your instance, including the public DNS, instance types, and other details that you would need. So to connect to this instance, click on Connect. You can see that there are various ways to connect to your instance using Session Manager, Console, and SSH. We'll be using the SSH client for now. So for Windows users, we'll have to grant permissions for the downloaded PEM file only to the current user and remove all other user permissions. So let me go to the downloaded folder. So this is the PEM key. Right click on Properties and hit on Security, Advanced, and let me disable all the inheritance. So this will essentially remove all the inherited permissions from this file. So let me click it, and once that is done, let me add myself to this particular file's security. Click on Add. I'll select a principal. You'll have to type in your username, especially the Windows username, hit OK, and give full control over it. Once that is done, click on OK, apply the changes, OK, and OK. Now this PEM file is ready to be consumed for SSHing into the instance. So let me go back to Management Console. I will be copying this sh command, which you will have to run at the terminal wherever the PEM file exists. So that is demo.pem, followed by the EC2 user, which is the default user of the instance, followed by the DNS name. So let me copy it. I'll go back to the folder again, right click, open in terminal. Let me pull the terminal back into the window. I'll just clear the screen and paste it here. So since this is a new host in our terminal, we'll have to confirm its identity. So let me just enter in yes. That's it. Now we are into the system. Now we'll have to install all the required SDKs and packages to our instance. Let me zoom this in a bit and let's start installing. So I'll just copy paste the command that I have shown you earlier from the GitHub repository. So on the same repository, you'll find a file called userscript.md where you can find all the scripts related to this installation. So I'll be going one by one. So the first step will be to update the instance index by running this command, sudo yum update. Let me copy this. I'll go back to the terminal and paste it there. So once that is completed, let me proceed with the other installation. That will be Git, .NET 8 SDK, and Docker. So let me open it up. I will copy the command of git, sudo yum install git, and click on enter. So depending on your network connection, this will take a couple of moments. Next, let's install .NET 8 SDK. We'll install Docker next. So once Docker is installed, we'll need to ensure that the Docker service is up and running. So for that, we have this command, sudo system control start Docker. Now we can see that Docker is started. So let me run sudo docker ps And you can see that we are able to access the Docker CLI. I would also add this command to ensure that Docker is up and running every time the instance reboots. So that is sudo system control enable Docker. So once that is done, we'll have to install the last package, that is the Docker Compose. I'll just copy paste the command for it. So once that is installed, we can verify the installation by running these following commands. So you can see that we have .NET 8 installed, Docker installed, and Docker Compose installed. Now that we have all the required components installed on our machine, the only remaining task is to pull in the .NET source code. So let me go back to my repository. I'll click on code, HTTPS, I'll copy the URL of this. I'll navigate back to my terminal and type in git clone followed by the URL. So once the code is pulled, let's navigate into that. So the path will be cd .NET on AWS series, cd hosting, and inside that we have a folder called bookmanager.api. Select that and let me hit an ls. So you can see all the required files are here, including the Docker Compose file. So the first step would be to publish a Docker image. For this, we'll have to run a .NET publish command. Let me copy that. I'll paste it here. So it'd be a .NET publish with a release configuration as a self-contained container. Let me hit on that. This would trigger the .NET build, publish, and also generate the Docker image for us. As you can see, the book manager image is published to the Docker. So just to clarify, I had added a sudo to the command just to ensure that enough permissions are there to publish to the Docker container. So to cross verify this, let me run a sudo docker images. As you can see, we have two images with the tags as 1.0 and late is running. Now to spin up the entire application, we'll have to use Docker Compose. For this, let me run sudo Docker Compose up -d to run the entire application in a detached mode. Let me click on enter. So this will start pulling all the required images. So once the Postgres image is pulled, it will create a new container. The book manager API will be waiting for it. And in a couple of moments, both of these instances will be healthy. Now, to check the logs of the container, let's run this command. Sudo docker logs, the name of the container, that is book manager, followed by an -f. And as you can see, as expected, we have the container running at port 8080. The final task is to make our instance publicly accessible at this port. For this, let's switch back to AWS Management Console. I'll open up the instances. I'll open the current instance ID. Let me navigate to security. Let's open up the security group that is attached to this instance. We will be editing the inbound rule of this. Let me edit the inbound rule. The first thing you notice that we already have an SSH access to this, which is actually allowing the access through the port 22. Let's add a new role. We'll give a custom TCP. The port range will be 8080 and the source can be anywhere from the internet. At the same time, we can also add description, which is optional. Let's click on save rules. I will navigate back to my instances. Let's open up the demo instance that we created. I will copy the public DNS, open up a new tab, paste it there, followed by 8080. And there you go, we have our welcome message. Now we can see that our API is publicly accessible. So to test this, I have created a Postman collection. Let's open that up and click on the first endpoint, which will get all the books from AWS. So let me click on send. And as you can see, we are getting an empty array since we don't have any entry in the database. Let's create a new book by clicking on this post command. So this is the URL and I have prepared a demo payload. Let's post this. And you can see we have a 201 created response. At the same time, we can also go back to the first endpoint and click on send. And you can see that we are getting back the data. Let me copy this ID, open the next endpoint, which can get the book by ID, and click on send. And there you go, everything working as expected. So this is how easy it can be to run your own instance on the cloud, at the same time have complete control over your hardware. So as mentioned earlier, I have already covered all the other AWS compute options like ECS Fargate, Lambda, Elastic Beanstalk and AppRunner. If you haven't checked those out, make sure to have a look. And let me know in the comment section what you might think might be the best hosting solution for your .NET application on AWS. I am thinking about putting together an article and video comparing all these AWS compute services side by side to help you make very informed decisions. So if that's something you would like to see, drop a comment down below. And regarding our EC2 instance, make sure that you terminate the instance once you're done with testing. This ensures that the AWS builds are under control. So let me click on instance states and you get an option to stop the instance and terminate the instance. I will terminate mine. For a text version of this video, you can refer to this blog post. I hope you like this video. Make sure to subscribe to my channel and hit the bell icon so that you are notified every time I drop a new video. In the next video, we'll be doing a head-to-head comparison of all the AWS compute services and help you decide when would be the best scenario to use which service. Until then, thanks for the time and have a happy week ahead.